Here, the light bulb is the resistance. Energetic charges, tired charges. The charges are turning on the lights. We can see that number 2 makes the charges more tired than number 1. You can see the difference in tiredness, potential the charges feel before and after passing through the 2 light bulbs. There is a difference in how tired they become, which is the potential difference or voltage. The charges get more tired passing through number 2 than number 1, which means number 2 has a higher voltage. The symbol for voltage is V and its unit is volts. We use a voltmeter to measure it. I see. The difference in tiredness is the voltage. If there is no voltage, there is no work to be done, so the charges won't flow through. Doing a lot of work means the resistance and voltage are large. Exactly. See the voltage. If the voltage between A to B is 10 volts and B to C is 20 volts, the voltage between A to C is the sum 30 volts. Cells have the role of energizing the charges. When connected from plus to minus, the cell sends out the charges into the circuit. This is the symbol for the cell. The long line is the plus terminal. The short line is the minus terminal. When the cells are connected in series, the voltage is its sum. 10 volts would be 20 volts altogether. When the cells are connected in parallel, the voltages don't change. Even with 2 batteries, the voltage remains at 10 volts. The charges become more energized when the cells are connected in series, but the cells will be used up quicker too. Cells not only re-energize the charges, but also push their backs to flow through the circuit. When there is connection to the ground wire, all of the charges' energy gets taken and they can no longer work. Now, let's connect cells with differing voltages. What would their potential difference be altogether? It's just addition, right? Oh wait, the cells are in reverse directions. When the cells are in the same direction, their voltages would be sums. 10 volts plus 6 volts equals 16 volts. When they are in opposite directions, their voltages would counteract. 10 volts minus 6 volts equals 4 volts. When connecting a voltmeter, be careful of the positive and negative terminal. Depending on the size of the voltage, you need to choose the 300 volts, 15 volts, or 3 volts for the minus terminal. This changes the scale, so you need to watch out. Voltage can be compared by looking at the charges, so it must be measurable. We need to see the difference between the energetic and tired charges. The path the charges flow through is called a circuit. By looking through the eyes of the voltmeter, we can determine the difference between the energetic charge and tired charge. This difference is the voltage. Because we are just measuring the difference, the voltage will be the same between any 2 points of the circuit that have charges flowing with the same tiredness. Since the voltmeter is also connected to the electric flow, it should have some resistance, right? It is parallel to the circuit. Exactly. This is why the voltmeter has a large resistance to try to stop charges from flowing through.